All right, so hopefully you just spent some time looking over your Pythagorean theorem, doing a little review there, finding the measure of the angle using your ratios, and we are then going to move on to our next topic. Close out that. Topic 2, which is finding the side lengths or angles when the triangle is not a right triangle. So far in our trigonometry class, we've been focusing on using the Pythagorean theorem and using trig ratios, so SOHCAHTOA. All sorts of alerts today. SOHCAHTOA to get our trig ratios, and then we can use the reciprocal functions if needed. But the thing is, in both of these situations, we were dealing with a triangle that has a right angle in it. So it had a 90-degree angle that we would use, and then you could use SOHCAHTOA or Pythagorean theorem. Well, today we're going to look at a different law called the law of sines. Sines like opposite over hypotenuse, not signs like a stop sign. It can be written in two ways. Basically what we're going to be doing is writing some ratios. So I'm going to show you two different ways to write these ratios. These come from a much longer proof for which you can find a video on YouTube to explain the law of sines and where it is derived from. But for our purposes, I don't know that that information is important in order to complete this video. So when we talk about ratios, we are comparing two things. So I'm going to compare side A in the triangle with the sine of the angle opposite. Then I'm going to say that that is equal to side B in ratio with the sine of the angle opposite. Now, this is all well and good comparing two sides and two angles. We also know that within a triangle, though, we're going to have three. So this could be side C as compared with sine of the angle opposite. Now, when we solve proportions in math, we don't use three different equations, right? We would just say that these things are equal. You can leave the one that you just wrote down with C over sine C, but that means we also could use that A over sine A is equal to C over sine C. We also could use that B over sine B is equal to C over sine C. And those are all going to be equivalent because we are setting up proportions comparing those ratios. The angles version is just going to be the reciprocal. So I'm going to say that the sine of A compared with side A is equal to the sine of B compared with side B, which also could be written as the ratio of sine C over C. But again, we won't set all three of them equal to each other at any given time. So you could just call this sine A over A equals sine C over C. And then the last one would be sine B over B equals sine C over C. And you'll see that the angles and sides version, they're the same. It's just a reciprocal. So I actually wouldn't focus too much on which one to use and when. I would just commit one of them to memory. And remember that you are setting up a ratio of the side of the triangle compared to the angle opposite. When we talk about angle opposite from geometry class, I should draw that so it's not a right triangle. When we talk about angle opposite, so if this is angle A, this would then be side A. If this is angle B, this would be side B, which makes this angle C and this side C. So we talk about the opposite side within the triangle. Now, all of these proofs, as I mentioned, you can find a video to find the proof of it, but it comes from drawing in the altitude and creating some right triangles to use the sine function. All right, so when can you use the law of sines? First, we need to think about geometry, and when we used to talk about triangles being congruent, or if we think about the concept of a unique triangle. So if I give you three sides of a triangle, there is only one triangle in the universe that can have those three sides. And so if I give you, let's say, a side length of a 5, a 7, and a 6, you can only put those together into one type of triangle. Okay, so that means it's a unique triangle, or it's got its own congruency, where if I gave you another set of things that were 5, 6, and 7 in length, you would find that exact same triangle. The same is true if I give you two angles and a side sandwiched in between them. The same is true if I gave you two sides and an angle sandwiched in between them, or if I gave you two angles and a side not sandwiched in between them. So from geometry, what this would look like is if I gave you 3 sides, if I gave you an angle, a side, and another angle, if I gave you a side, an angle, and another side, or if I gave you an angle, and a side not included. Okay? So for the law of sines, we're going to focus on when we know more about the angles. These two are going to be the law of sines, which makes sense because we have our ratio that is dependent on knowing the sine of A, the sine of B. We need to have information about our angles. We'll focus on these two when we get to the law of cosines next week. So let's do an example because that helps. Find all missing sides or angles in the given triangle. So what I have here is I have a given angle, I was given another angle, and I was given a side. So this means I have an angle, and a side that is not sandwiched in between. So angle, and a side not sandwiched. Great. Angle, side was one of the ones that I can use the law of sines. So what I'm going to set up is figuring out, I still need to look for side B, angle A, and side A. Well, hopefully you look at this and you say, I remember there's 180 degrees in a triangle, which means that 105 degrees plus 40 degrees plus angle A has to be equal to 180. Well, thinking about that for solving for angle A, hopefully you got that angle A is going to be 35 degrees. So I got that part filled in. And now I want to find my missing side lengths. Well, this is not a right triangle, so I can't use SOHCAHTOA or Pythagorean theorem because I don't have a hypotenuse. So instead I'm going to use this new law of sines. So I'm going to set up a ratio for a side and an angle that I have a pair. So I know 105 is across from 120. So I can set up that the 20, did I say 120? 20. 20 over the sine of 105 degrees must be equal to, well, here's another thing that I need to find. Oh no, my computer is really struggling today. Side A over the sine of 35 degrees. Well, now I can use my remembrance of proportions, and I'm going to multiply 20 sine of 35 will be equal to A times the sine of 105. So going to your calculator, you want to make sure you're in degree mode because we're working in degrees. And I'm going to say 20 times the sine of 35 gets me that side, 11.4715. And I'm just going to leave that in my calculator. And I'm going to divide then by the sine of 105 degrees. And I get that A is equal to 11.876. So there's my side length of A. And I've got angle A. So this was 11.876, which means the last thing I need to find is side B. Well, I'm looking for side B. And side B is across from 40 degrees. So I'm going to take the sine of 40. And I'm going to set that again to that ratio of the nice one that was given to me that I knew. I knew for a fact that 20 was related with the sine of 105. So take a second, cross multiply that, pause your video, and let me know what you get for side B. All right, so hopefully we came up with B is equal to about 13.3. I rounded my decimals in my answer key, so hopefully that's okay with you. But really you're just doing your multiplying, right? Because we've got a proportion, and you should end up with 13.3. All right, next example, what type of congruency? It's important to establish what was given to you versus what you're looking for so that you know what law you can use. So it looks like I was given an angle, I was given this side, and I was given this angle. Well, that looks like an angle, a side sandwiched in between, and another angle. So angle, side, angle. Luckily for me, that means I get to use the law of sines. So the things that I still need to find are angle A, side B, and side C. Again, I'm going to start with finding that angle A because I know that there's 180 degrees in a triangle. So I'm just going to subtract from 180 and I get that angle A is 77. Well, now because I have 77, this is a nice side and angle pair that I can set up my ratio. So we would say that 38 over the sine of 77 degrees is going to be equal to, I'm going to do C first, so C over the sine of 48, and I'll be able to solve that. The other ratio I can set up then is 38 over sine 77 will be in proportion with side B over the sine of 55 degrees, because B is across from an angle of 55. So go ahead and cross multiply, solve for B and C, and just round to the nearest whole number. Take a second to do that, pause your video, make sure you're okay with your calculator. Okay, so for this one, we should have gotten that C is 29 centimeters and B is 32 centimeters. A good way you can check the reasonableness of your answer is that within a triangle, the bigger side should be opposite of the bigger angle. So we had an angle of 77 degrees, and that had a side opposite that was equal to 38 centimeters. We had an angle of 55 degrees, and that had a side opposite that was 32 centimeters. And then we had an angle that was 48 degrees, so the smallest angle, it should make sense that our side C was our smallest side. Now, they're not directly in ratio with one another. That's why we use that sine value. Again, comes from a bigger proof with drawing in an altitude and thinking about a right triangle snuck inside that oblique triangle. But a good way to check reasonableness is that the bigger angle should be with the bigger side in terms of sitting across from each other in the triangle. Okay, so on the next page, you have some extra practice. I'm going to make a video of problems 2 through 5. That's just there if you need to check your work, okay? So you can listen to it if you want to, and I'll take you through the explanations of each one of them. But if you feel like you've got a hang of this thing and you're going to use the law of sines just fine, go ahead and just do them and then check your answers with your teacher or with a neighbor, or use the video just to check your solutions and make sure that everything is going well. And that's basically your summary for the law of sines.